There's currently a race amongst the tech giants to develop the first fully autonomous vehicle. This project explores autonomous features on a smaller scale by focusing on radio-controlled vehicles. At my disposal is the Vatera V100-C RC car. It will be connected to both an Arduino Uno R3 and a Raspberry Pi 3 Model B. The primary function of the Arduino Uno is to control the electronic speed controller and the steering servo, while the primary function of the Raspberry Pi is to get the input from the Raspberry Pi camera module and convert it into steering instructions that are sent to the Arduino Uno for it to execute. The need for the Raspberry Pi arises from the necessity to utilize the OpenCV software. The OpenCV software needs to run on an operating system such as the Raspbian operating system that's running on the Raspberry Pi. Since the OpenCV software is resource intensive, it's best to split apart the video processing from the servo control, which is why we also have the Arduino microcontroller doing that processing. Aside from the servos and video input, there are also going to be 5 ultrasonic sensors that are going to be connected to the Arduino Uno. The ultrasonic sensors will aid in obstacle avoidance. The first phase of the project was to identify and understand the parts that make up the Vatera RC car. A thorough understanding was needed of the ESC and the servo motors that drive it. The next phase involved connecting the Arduino Uno to the ESC and the steering servo. Phase 3 involved connecting the Arduino Uno to the Raspberry Pi. The Arduino program was installed on the Raspberry Pi and a test integer value was sent to the Arduino. The installation was pretty straightforward. It involved opening the Raspberry Pi and typing in the following command. OpenCV installation was next on the list. To install the OpenCV software, the following commands were executed within the terminal program on the Raspberry Pi itself. On the same day, the ultrasonic proximity sensor was also attached to the Arduino. Next was attaching the Raspberry Pi V2 camera module to the Raspberry Pi itself. A small test program was created utilizing the OpenCV to capture video footage. Video footage of a vehicle driving on a road was downloaded, and OpenCV software was utilized to convert it into a format that would be needed for the autonomous RC vehicle. Most details were stripped from the footage, and the remaining footage consisted of black scenery with white lines. The white lines represented the road lines, of course. A small segment of the video footage was cropped out, focusing on the shoulder line. This small segment will be crucial for translating the video footage into steering controls. The remainder of the project will consist of doing the following tasks: translating the OpenCV video captured footage into steering instructions, connecting 4 additional proximity sensors, and utilizing those proximity sensors for obstacle avoidance. The last step will of course be to construct a test track where the RC vehicle will actually have some real-world driving experience. The first milestone was to connect the Arduino Uno to the ESC and the steering servo. Second milestone was to connect the Raspberry Pi to the Arduino Uno and send a test signal to it. Milestone 3 was connecting the Raspberry Pi V2 camera module to the Raspberry Pi. This camera module will be crucial in converting road footage to steering instructions. The next milestone will be achieved when all 5 proximity sensors are installed and obstacle avoidance is achieved. The last milestone is to construct a test track and have the RC vehicle navigate it successfully. There are a number of other RC autonomous vehicle projects out there. The Donkey self-racing car platform utilizes machine learning. The training commands are executed on the PC, while the autopilot commands are executed from the Raspberry Pi itself. Another example of the autonomous RC vehicle was developed by Zheng Wang. It utilizes a similar platform to the Donkey car racing platform. However, all of the computation is done on the PC. It seems that most autonomous RC vehicles follow a similar approach. They utilize the OpenCV software and a microcontroller. The main difference between this project and the others is that this project does not utilize a neural net for autonomous vehicle functionality, while the others do.